Good evening, everyone. My name is Avina Mariel, and my metric number is CE200108. And we are from Group 1, where we'll be presenting for Chapter 2, which is the Industrial Sensor. So we'll go through to the introduction and the inductive proximity sensor. Before we begin for its theory and operation, we shall go through the learning outcome. So we have known that the sensor is widely used and it is very important for the industrial automation system, as it provides great accuracy and precision. Also, it is also able to work in harsh environment. So by the end of this chapter, the student, which is us, are able to identify and classify the types of sensor that are used in the industrial automation system, and we are also able to use the selected sensor that are available for a specific application. So the next part is where we have to learn the basic concept of a sensor, which is what is a sensor. So a sensor is basically a device, which is a transducer, that converts a physical stimulus from one form into more useful form to measure stimulus. So which means that it is a device that it is able to detect or measure a physical property, and it can even respond to it. So I'll give you an example, which is the proximity sensor, which the proximity sensor works like every sensor do, where it detects object by its physical contacting them, where it converts information of a movement or a presence of an object into an electrical signal. So for example, our smartphone. So next, these are the type of sensor that are used for the industrial automation system, which is the proximity sensor, the photoelectric, and the miscellaneous sensor. So for the proximity sensor, it performs a non-contact detection in comparison to sensor that, for example, the inductive and capacitive sensor, where it's detect object by physically contacting them. Next is the photoelectric sensor, where it also used to determine the distance, absence, or presence of an object by using a light transmitter. Usually it uses an infrared and a photoelectric receiver. And last but not least, the miscellaneous sensor. This miscellaneous, the meaning of miscellaneous means that it is a mix of a lot type of sensor into one. So this sensor detect change a signal received from an LED due to either smoke or any object in the light path from the LED. That's all for me. Thank you.
Greetings, Sister. My name is Chitran. Now I am going to explain about the proximity sensors. So proximity sensors is divided into two types. It's like one is inductive and another is capacitive, like previous presenter said. So for the industrial automation, is widely used like conveyor lines for counting and jam detection, etc., etc. Then machine tools, safety interlock and squeezing. So it's usually using the digital concept like on and off sensor, detecting the presence and absence of an object. Is most likely for the metal object. So later I will explain about the object for the metal one. For it, the proximity sensor consists of sensor is like optical, inductive, and capacitive. Like I said, is a detector circuit, amplifier. Then output circuit will be TTL, that solid state relay. So proximity sensor is a sensor that gives a switching signal when the object passes at a close distance to it or within a later sensing distance. There are also several ways to producing a signal, switching signal, including magnetic field, ultrasonic reflection, high frequency, interactive interfaces, interference, or high frequency capacity interference. So it's most likely like I told you, like metal one. So metal is like for the magnetic field. So here. So here's the interactive one and capacitive one. So for the interactive proximity sensor, in the inductive type, the moving object that passes through an high frequency magnetic field is produced by the sensor will change the circuit into the circuit inductance, so that so that the circuit current, which operates a relay to produce a switching signal that gives the type for sensing the metal object. So this is why. So I pass this to the second presenter to explain more further about the inductive and capacitive proximity sensor. Thank you, Doctor.
Good day, my name is Aziz Azan Adetayo, and my matric number is AE2075. So I'm going to take over from here. One of the applications of inductive proximity sensor is that it can be used in counting teeth in gears. Yeah, since the basic use of the inductive proximity sensor is to detect metals, then it's safe to say that the inductive proximity sensor can be used in counting teeth in gears. So other forms of applications of this inductive proximity sensor involves or includes it can be used in phones and mobile phones and other telecommunication gadgets. It can be used in recycling plants. It can also be used in autonomous driving cars or self-driving cars, and then it can also be used in anti-aircraft systems, yeah, air defense systems in the military. So from there, I move to, here's a diagram of uh, the working principle of this inductive proximity sensor. This diagram it displays, or it contains, the operative or the mechanism at which proximity sensor works, the working principle, how the inductive proximity sensor works. So here's the sensor. Yeah, here's the sensor, which contains a sensor head. There's an oscillator in it, and there's this trigger, and then there's an output made from amplifier. So here's the material to be detected: conductive metal. So the head of this sensor produces an electromagnetic field at a very high frequency, and then there's an oscillator that generates an alternating current, and then this trigger dictates any changes in inductance, and then the trigger relays into the amplifier as output, and it goes on like that. So that's just the summary, that's just the overview of how this sensor works. So here I'll talk about the basic construction and circuit makeup of the inductive proximity sensor. So mainly the inductive proximity sensor is made up of 4 main parts or circuits: the sensor head, the oscillator circuit, the detector circuit, and then the switching circuit, or otherwise known as output. So here's the diagram showing the mechanism or the operating principle of this sensor. So here's the sensor head creating an alternating current, and then oscillator relaying it to the detector, and then the detector relays to the output. And then I'll hand over to my mate to explain in details the operating principle or the mechanism of this inductive proximity sensor. So that will be all from me. Thank you.
Good morning, doctor. My name is Yongkit Somkat, matrix number DE 2026. So for my part today, I want to explain for the operating principle for the sensor head, oscillator circuit, detector circuit, and also switching circuit for the output. Okay, let's go for the operating principle for the sensor head. So it consists of the wire wound ferrite iron core, and the second one is it is the physical part of the sensor that produce the actual sensing field. That means when this sensor head detect the upcoming metal, past the magnetic field that produced by the sensor, it will change the circuit inductance. Then let's go to the next one, which is the oscillator circuit. So for the oscillator circuit is the consists of the circuit that power the wire winding from the sensor head. It also can monitor by the detector circuit for resulting detection. So that means this oscillator circuit, it will strengthen the signal so that it can activate the relay in this circuit. So the next one is sensing a moving target. Okay, as we can see from this, when the sensor can sense the moving object, so the amplitude of the oscillation will activate, will give us sinusoidal signal. And let's go to the third one, which is the detector circuit. So the detector circuit will convert the amplitude of the oscillating signal to the DC RMS level, which is it will tell where either the sensor will turn on or turn off. So we use the observe the voltage level in the detection circuit. So if the voltage level is reach the certain level, so it will turn on, or either one, it will turn off or turn on. It depends on the voltage level that come inside the circuit. And then for the last one, let's see for the switching circuit for the output. So for this circuit, the output circuit, it handle the actual switching and control of the output. That's all from me. Thank you.